In this lecture, we cover the fifth normal form. Before you watch this video, we recommend you to watch our earlier videos of this series for first normal form, second, third, BCNF, and fourth normal form. Before we start fifth normal form, let us just have a quick recap or refresh of previous normal forms. The first normal form covers the basic rules like column should have atomic values, column name should be different, and they must contain the similar type of data types. Then the second normal form says there should not be any partial dependency in the table. The third normal form says no transitive dependency should exist. Then comes the BCNF, which is also the 3.5 normal form, and finally the fourth normal form, which says no multi-value dependency to exist. I would again recommend you to watch earlier lectures to get a hold over all these normal forms. For a table to be in fifth normal form, it should be in fourth normal form and should not have any joint dependency. Just like other normal form, the fifth normal form also comes with a dependency concept, which is joint dependency, and because of which it is also known as PJNF, that is project joint normal form. In similar words, if a relation has joint dependency, then it can be divided into small relations such that if we combine the small relations, we get the original table. It is confusing, but that is the basic idea. Here we have the table A, and suppose if we divide it into two pieces, that is B and C, then again if we combine those tables, and it gives us the resultant table. If the resultant table is similar that of our original table, then all the dependencies are preserved and we can say that we are allowed to divide this table. Otherwise, fifth normal form recommend us to not split the table. Here, two cases are possible. If we got the same data after division and rejoining as it was in the original table, then we can break down the table. It's allowed and it's fine. Otherwise, there can be a loss of information, that's lossy decomposition, or addition of some data, that is spurious tuples. If that is the case, then we should not split the table. Let's take an example. Here in this table, we have supplier, product, and customer as three attributes. And via ER diagram, we can represent them like this because there is a ternary relationship between them. As per the ER diagram, the relation we can say a given supplier can supply a given part to either one or more customers. Similarly, a given customer getting supplied by a supplier can have one or more products. Or a given product used by a customer can be supplied by multiple suppliers. Here, if we divide our main table into three sub-relations, then we found in first table we have supplier product, then product customer, and then supplier customer. With this example, we can conclude that the supplier Acme is going to supply the product 72X SW. And to whom it is going to supply, we don't know. Where in the second relation, the product 72X SW is supplied to a customer Ford. In the last, we can say that supplier Acme is supplying something to the customer Ford, and what it is supplying we don't know. Which product? Is it E-switch or 72X? We don't know. By individual we can conclude these three statements, but we can't conclude Acme sells 72X SW to Ford from these three individual relations. So we can say that this is not preserved, or we can't conclude it. That's why fifth normal form says that if there is no loss of information after rejoin, then you can divide the table. Otherwise, you must not do so.